Hi, my name is Sean Ellis, and this is a presentation regarding data mining and phishing detection. So the goals of this presentation is to provide some insight into the complexity of phishing attacks, provide some background that was used to conduct the data mining and generate effective defense against the attacks. And I'm hoping to clarify some areas of newfound knowledge. Some of the research papers use terms in that was unfamiliar to me. So phishing generally is the art of data extraction from the human through technical and social prowess. Data mining is the art of discovering patterns or information within large data sets. So what is phishing? Phishing is basically a scam where an attacker will use some sort of method to convince a user to provide information such as financial information or user credentials, say logging into a bank account. So usually they can be done through phishing emails or through a phishing website. This research I've done so far has mostly focused on phishing emails, and then from the email that can lead to a user being redirected to a phishing website. So regarding emails, there's a basic type called just a phishing email, and it is a broad spectrum send out by the attacker, hoping that he catches somebody that will click his link or enable his malicious software. There's also spear or whaling phishing emails. These are targeted. These are more specific to a group. The attacker will use very specific content to entice the victims into clicking phishing links or opening malicious attachments. There's also something called smishing, which is the use of short message service or SMS text to try and infect a cellular phone or convince the user again to use the cellular phone to go to a malicious website. There's also something called phishing, which is the same idea except is actually done by voice using a telephone. The attacker will physically call the victim and try to extract data. Now for the report and for this presentation, smishing and phishing are not included. So this diagram here is showing just the basic concept where we would have the attacker would first set up a malicious website. He'd either infect it or create his own. Second, the attacker would generate either the malicious email containing malicious links, or would even set up some infected files and attach them to the email. Now, the user would now have a dilemma. He receives the email and has to make a choice. He has to analyze the email and figure out, is there anything funny in it or is it legitimate? So there's a few options. Well, if he believes the email is phishing, he could just ignore it and delete it. If he somehow believes the email is legitimate, he could select one of the malicious links, which could redirect the user's web browser to a website, and usually a pop-up or some sort of form would be used in order to gather the victim's credentials or financial information. The victim or the target would believe that they were at a legitimate website and they would enter the information. The other thing that could happen is just by visiting certain websites, depending on how it's set up by the attacker, the PC could be infected depending on vulnerabilities of the actual PC, usually through vulnerabilities of the web browser. Now, the trick for the data mining is to stop the actual user or provide indications that the attack cannot go past the user. This is an example of a phishing email. It's a common one. I receive a lot of these. It's regarding Apple. So in this one, normally the attacker tries to figure out or tries to duplicate a legitimate site. So in this case, you could tell something's funny because the email address from the sender has nothing to do with Apple, even though they have the words iCloud put in there. Some of the other tricks they use is to CC legitimate looking email addresses, but again, most of those are fake. Here, this is where the social engineering comes into play, where the attacker tries to convince you that it is something to worry about. He tries to create anxiety. He's telling you here that your Apple ID is locked. Oh no, what are you going to do? But don't worry, they can verify and unlock your account if you verify your identity. This is that carrot to get you to try to click the link down below. And they also create panic by saying if you don't comply with this email, your account will be permanently locked, which is a complete lie. But this is the social engineering tactics used by the attacker. So this here is a button. It looks innocent enough, but the actual link that the button points to is a strange email address. And in this point here, they're using an IP address, which is actually a sign of phishing, which will be described a little further on. So according to some research done by Mohammed, Tabith, and McCluskey, phishing website features, they have generated sort of a standardized set of features that can be used as data for data mining. So one of the biggest challenges was that the data so far is non-standardized and is unreliable. For two reasons. One, researchers haven't agreed on what the data set should look like. And two, the attackers continually change tactics, so the data will change. But here I'll list a few of the important features that do come into play. One of them, address bar features, like using the IP address. As I demonstrated in the previous example, having the IP number in the link is not a good sign that the link is valid. Another thing is long URLs to hide the suspicious parts. If you look at this example, there's a couple things. One, it's very, very long, but you'll also notice an @ symbol towards the end, phishing.website.html. That would also give a clue of phishing. The other one is the use of URL shortening services to hide the actual intent or the actual address of the malicious site. Other tricks they use, they include the @ symbol, redirection with the double lines, or incorporating hyphens, which is not common in most legitimate email, or not email, but URLs. As well, one of the things the data scientist could check for is the number of dots in the domain part of the URL. So an example here, u.ok seems okay, but if I uk.ok. something else, could be suspicious. So the rule sets that they use right now is more than one dot, it's suspicious. One of the standard tricks that could be used to determine if the URL was pointing to a phishing site is looking for the S, which stands for secure in the HTTP transfer protocol. So normally the site, if it didn't have the S that indicated a secure socket, then you would know it was a phishing attack. However, this has changed over the years because now attackers can self-sign certificates and therefore can create malicious websites that do have the secure socket. So in my opinion, this is no longer a valid feature that should be used. Other things that the data scientist can look for is domain registration length. If it's less than a year, it's probably bad. Using non-standardized ports. Normally firewalls and such will have default ports, unnecessary ports turned off, but it'd be a good idea to check which ones are being used as a preferred status. Look for URLs from another domain. Definitely an indication of phishing. An interesting one noted in some of the research I found is the URL of anchor, the bracket A bracket tags, or in the HTML tags. If the URL inside these tags are pointing to different domains, most likely it's going to be phishing. Another one is if the anchor link does not link to any web page. It's empty, or it has something like href equals javascript ... That could definitely be a sign of phishing. And as well, anything in the metadata, such as links, again, point to different domains. Another feature that is useful is catching the submitting information to email. This is not normally used in legitimate sites where the mail to or the mail function is used for the user to submit information. This normally is associated with a form or some sort of other pop-up. Another feature that's used is website forwarding. Legitimate websites normally only redirect one time, but they found phishing websites to redirect at least 4 times. Other thing to watch out for, of course, is JavaScript or other scripts running. JavaScript is quite powerful. You could fake the URL. I tell people to always look at your status bar on your web browser in order to determine or understand if you're actually at the site you're supposed to be at. Other tricks are disabling right-click. Therefore, you cannot gather information from the particular site, like view source. Another common one is pop-up windows for the user to submit the personal information or financial information. Legitimate websites usually has the forms embedded directly into the website. So, during all my research, one of the latest related work or sidebar I encountered was I used Firefox most of the time for research, and I noticed I had some add-ins added. I used Ghostery, NoScript, and Privacy Badger. This is to try to keep the tracking cookies and other tracking software at bay. Now what I noticed, I had nothing for phishing detection. So a little further research, I found this one called Netcraft. I did load it in. It had over 8,000 users. It's still undetermined to have it effective. I might load it into one of my VMs and play with it, go to some sites that could be questionable to see if it works. But right now it's undetermined. What I did for this research paper is I use a simple form of research using data mining to help me understand the mechanisms to actually what was being used towards phishing detection. So this one here, I've noted from CAD and Dr. Sinead, they incorporated the use of fuzzy logic and they used the Ripper algorithm to detect phishing emails. So they did note that phishing website or detecting a phishing website is a very complex problem because it has the two technical and social aspects connected together. They did introduce the idea of fuzzy logic and linguistic variables. These are two things I didn't understand at first, and I had to do a little more further research. So the data set that they did use, they gathered from sites called like Fish Tank. They bounded their data set so that it primarily focused on the phishing email and the phishing website that it was pointed to. It did not take into account things such as malicious attachments or any embedded malware. There's been some examples where hex code and that can be sort of hidden and reactivated in HTML code if they have turned on HTML for their emails, for the victim turns on the HTML code. And the other thing it doesn't take into account is drive-by attacks where a user just web browses to the phishing website, which can then again infect or cause other problems. So the Ripper algorithm, I had to do a little more research on that. I didn't even know what it stood for, but it's the repeated incremental pruning to produce error reduction. It's a proportional rule learner. It works like a decision tree, but it uses a very aggressive pruning on each iteration. The neat thing about it, the training data set split into two parts, a growing set and a pruning set. The algorithm is fairly simple. First, you start with an empty data set. You build. So as you're building, you repeat the grow and prune steps until the description length is small as possible or there's no positive examples left. Basically, the grow phrase is very, very greedy. So one rule, You grow by one rule, and you add the antecedents to the rule until you have reached 100% accuracy. Now the pruning phase, it prunes again at every iteration. And one of the characteristics of RIPER is that it does prune very aggressively. The next step is to be optimize. So you generate and prune two variants of each rule from the randomized data. One variant is generated from the empty rule, while the other is generated by greedily adding antecedents to the original rule. So this is where it shows that it iterates and you're pruning. So it's like a decision tree where you can very quickly cut out the extra legs that you do not need. And of course, the cutting out is that you do that in the delete steps. Now the researchers used these two topics, fuzzy logic and linguistic variables. Well, fuzzy logic is where the truth can lie between 0 and 1 inclusively. So basically you can have a partial lie or a partial truth. Now fuzzy models is just a way to represent imprecise information, but with a kind of a certainty or a bound of some precision. Now linguistic variables, I've never heard this term before, but it's basically a way to present imprecise data in a manner that represents a precise response. So the example I have here is the term hot. Well, the term hot could indicate that you don't need to wear a jacket, but it's not as precise as saying it's 28 degrees centigrade outside, which means you don't need to wear a jacket. The research demonstrated clearly that the URL and email content are valid criteria or features that can be used to determine. So they set their output or their results as either valid or genuine or fraud. Fraud was used as an indication of phishing. They did use some of the results to shut down malicious sites through notification of site admins. It was also noted the classification accuracy was 85.4%, which is pretty good, and incorrectly classified at 14.6%. Through further research, I found another research paper that provided detailed comparison of 8 different machine learning algorithms. They used a comparison data set of 30 features and over 11,000 examples, so it was a fairly large data set. Data was collected from 2 different sources, Fishtank and Miller's Miles. I have the, as indicated by the URLs here. And here are the 8 machine language algorithms: C45, Enhanced Dynamic Rule Reduction, REDOR, One Rule or 1R, Conjective Rule, BaseNet, Sequential Minimal Optimization, and AdaBoost. So the C45 algorithm is basically it's a decision tree developed by Ross Quinlan. It's an extension of Quinlan's earlier ID3 algorithm. The decision trees generated can be used for classification, and this is why it's often considered a statistical classifier. The enhanced dynamic rule induction discovers the rule one by one per class and primarily uses a frequency threshold to limit the search space for rules by discarding any items with insufficient data representation. For each rule, the algorithm updates item frequency that appeared within the deleted training instance of the generated rule. REDOR is basically an implementation of the ripple down rule learner. It generates a default rule first and then the exception for the rule with the least weighted error rate. It then generates the best exceptions for each exception and iterates until pure. I'm not sure what the term pure means. It performs like a tree-like expansion of exceptions. The exceptions are the sets of rules that predict classes other than the default. IREP is used to generate the exceptions. This is a definition right from the book. Still learning what it actually means. One rule or 1R is simply a classification algorithm that generates one rule for each predictor in the data and then selects the rule with the smallest total error as its one rule. Conjective rule implements a single conjective rule learner that can predict for numeric and nominal class values. The conjective rule uses the relation of logical and link stimulus attributes. The rule involves adding to the antecedents together with this consequent class value for the classification. BaseNet, as we looked at that a little bit in class, it's not a single algorithm, but it's a family of classification algorithms that share one common assumption. Every feature of the data being classified is independent of all other features given within its class. SMO, or Sequential Minimal Optimization, it's a support vector machine learning algorithm. The SMO algorithm uses a quadratic programming as an inner loop and decomposes the overall quadratic programming problem into subproblems using Osuna's theorem to ensure convergence. AdaBoost is a boosting algorithm which constructs a classifier. A classifier takes a bunch of data and attempts to predict or classify which class a new data element belongs to. Now, the algorithms chosen by the researchers were first, they needed to provide a meaningful test case to make the comparisons actually have meaning. The other thing that why they chose the algorithms was that they're common algorithms, they're well known, and they've been used in other applications. And they can be implemented in the Weka tool, and the Weka tool is what we've been learning in class. During my research, it was easy to find a lot of data on most of the algorithms, except for the EDRI algorithm. That one is still a bit vague, and I had a hard time finding information. According to the research, it showed clearly that the C45 algorithm demonstrated the highest classification accuracy. Now here I actually went back and I added the fuzzy and the ripper algorithm used by the first set of researchers I described. And it shows that it only had an 85% classification accuracy in red. So C45 definitely outbeat that one. Now the researchers, they concluded the C45 was the best. However, it did produce a much larger number of rules, 272. Now these were compared to the EDRI algorithm, which produced, I think, was 9 rules. However, these two plus the Redor algorithm are very effective in detecting phishing activities. 2 features of note: URL of anchor. I noted that above. It's a valuable feature in phishing data to use. And noted the SSL final state. To me, I'm not sure about this one because this ties in with looking for the secure, the S in HTTPS. And because attackers can now self-sign certificates, I believe this feature is no longer valid and should not be used. So, to conclude, phishing, it's insidious, it's complex, and it's highly effective. It requires advanced techniques to defend against. Yes, there's lots of research being done, but until data scientists start standardizing what phishing actually looks like and what features the best to use, it can still be problematic. There's been a lot of work, advanced techniques such as the EDRI algorithm. They're very good and proven at detecting phishing attacks, but there's still lots of room for continuing research. Thank you very much.